Programming Logic and Design, Chapter 3, Understanding the Structure. Objectives: you will learn the disadvantage of unstructured spaghetti code, the three basic structures, sequence, selection, and loop, using a priming input to structure a program, the need for structure, recognizing structure, and structuring and modularizing unstructured logic. Disadvantage of unstructured spaghetti code. Spaghetti code logically snarled program statement and often a complicated mess. Programs often work but are difficult to read and maintain. It is also confusing and prone to errors. Unstructured programs do not follow the rules of structured logic, while the structured programs follow the rules of structured logic. So for figure 3-1 spaghetti code logic for washing a dog, this is an example and part of unstructured logic. As you can see here in the arrow, it is very confusing for the people to understand this type of logic. So, understanding the three basic structures. Structure is the basic unit of programming logic. The first one is the sequence structure. This performs action in order. There is no branching or skipping here in any task. In terms of the second part of structure, which is the selection structure, also called decision structure, ask a question, take one of two actions, or dual alternative if, or single alternative of ifs. The third basic structure is the loop structure, wherein repeat actions while the condition remains true. This means that every time the condition is true, it will loop, but if the condition becomes false, the structure and the loop will stop. Figure 3-2 sequence structure. So this is the visual representation for sequence structure. Figure 3-3, this one is the visual representation for selection structure. There are two selection or condition, the yes and the no. Dual alternative ifs. This contains two alternatives. The if then else structure. If some condition is true, then do one process. But if the condition is false, it will fall here in the else. Else, do the other process. Then, as ending statement, there is end if the conditions are met. Single alternative ifs. If employee belongs to dental plan, then deduct $40 from employee gross pay. An else clause is not required because this is single alternative only. We have here the null case, situation where nothing is done. And for figure 3-4, single alternative selection structure, visual representation is provided. If a certain condition is no, then it will loop. Then if yes, it will go here in the rectangle. Loop structure repeats a set of action while condition remains true. It consists of loop body. Loop structure is also called repetition or iteration. Condition is tested first in the most common form of loop, the while do or the while loop. Figure 3-5 loop structure visual representation. If the condition is no, it will proceed. If the condition is yes, there is a certain um, condition here, then it will loop until it satisfies the condition. Loop structure. While test condition continues to be true, do some process. While you continue to be hungry, take another bite of food. Determine if you still feel hungry. This is an example. Um, all logical problems can be solved using sequence, selection, and loops. You can choose any of the three basic structures. Structures can also be combined in infinite number of ways. Stacking structure. This is attaching structures end to end. Now, when we say end structure statements, this indicates end of structure. The end if statement ends and if then else structure, while the end while statement ends the loop structure. In figure 3-6, structured flowchart and pseudocode with tree stack structure. As we can see here, this is an example of structured flowchart. The sequence part is the step of the step A and step B, while the selection part structure is the condition part, which has two choice of no and yes. Then for the loop, the condition in the lower part of lower part satisfies the loop condition. It is combination of the three basic structures. Nesting structure, placing one structure within another. Indent the nested structure statement. Block. When we say block, this is a group of statements that execute as a single unit. So here in figure 3-7, where flowchart and pseudocode showing nested structure, a sequence nested within a selection. Here in the condition, if condition is true, then it will proceed with yes, step J, K, and L, because it satisfied the condition for the nested structure as a sequence. While in figure 3-8, flowchart and pseudocode showing nested structures, a loop nested within sequence, nested within a selection. So we can see here that it has a nested loop condition in this part within the nested selection. Um, in other words, this is a combination of loop nested within a sequence and nested within a selection. So figure 3-9 flowchart and pseudocode for selection within a loop within sequence within selection. Combination again of the three. Here we have now the selection within a loop, within a sequence, and within selection. Combination of the three basic structures. So structured program have the following characteristics. Combination of the three basic structures. The structure has single entry point and single exit point. The structure can be stuck or connected to one another only at their entry or exit point. And last is, any structure can be nested within another structure. Using priming inputs to structure a program. So priming input or priming read, these are the first input data record. It is outside the loop that reads the rest of the record. This helps to keep the program structured. And for unstructured loops that do not follow this order, these are the steps that need to be taken. First, ask a question. Then, take action based on the answer to the question. Then, return to ask the question again. In Figure 3-15, structured but non-functional flowchart of number doubling problem. So, this is the visual representation. This logic is structured, but the program never accepts subsequent input value. So, it is structured, yes, but it is not functional because it is not accepting the input values. In Figure 3-16, it is functional but unstructured. The logic is not structured here. Figure 3-17, functional structured flowchart for the number doubling problem. So here is visual representation of a functional with structured flowchart. So here in the input, original number, it is declared as the priming input. While the input original number, this step gets all the subsequent inputs. For 3-18, structured but incorrect solution to the number doubling problem. Don't do this because this logic is structured but flawed. When the user inputs the end of file value, it will incorrectly be doubled and output. That's why it's incorrect. Understanding reasons for structure. Clarity, unstructured programs are confusing. Professionalism, other programmers expect it. Efficiency, most languages support it. The ease of maintenance, other programmers find it easier to read. The supports modularity, easily broken down into modules. It can be difficult to identify whether the flow chart is structured. Figure 3-20 example. This is an example of structured flowchart. While Figure 3-21 Example 3 is an example of unstructured flowchart because this program segment is not structured. The arrowed part here. Figure 3-23 Structured dog washing flowchart and pseudocode. This is the visual representation with respect to its flowchart and pseudocode. Figure 3-24 Modularized version of dog washing program. This is the modular version for the dog washing program with respect to its flowchart and pseudocode. So as summary, spaghetti code statements that do not follow rules of structured logic. The three basic structures, sequence, selection, and loop, combined by stacking and nesting. Priming inputs. Statement that reads the first input number prior to the starting of a structured loop. Structured techniques promote the clarity, professionalism, efficiency, and the modularity. Flowcharts can be made structured by untangling. Logical steps can be rewritten to conform to the three structures.